Today we will continue from our previous lectures. Last lectures we discussed how to find the integral for the sine and cosine when we have the odd power. Now we will continue how to find the integral for sine and cosine when we have even power. In case we have all the power even all day, what we will do, how we will find the solution, we have two steps. First step, we withdraw 2 from the even power to get the quadratic exponent, and then we can use the simplification relations for the double angle. These two relations are important and you should memorize it. We have sine square equal 1 minus cosine 2x all divided by 2, and cosine square equal 1 plus cosine 2x all divided by 2. Notice here there are these relations for the double angle. We have x here and the angle is become 2x, and we have x here and the angle become 2x. These two important relationships, you should memorize it. Second step, then we simplify the integration function more and more by expand the square or the cube. It depends on the type of the integrals. After that, the integral will be easy to solve. These the two steps. Take note for these two steps, or you can make a screenshot for these two important notes. And now let's go to see some practical example to make the pictures clear for this point. We have this example. Find the integral of the following function: integral cosine to the power 4 x dx. As we notice here, we have even power. We will solve this integral by following the previous step and everything will be fine. We withdraw 2 from the exponent. We have here 4. We withdraw 2, it will become 2. So the integral will become integral cosine square multiply cosine square dx. And we will use the relationship for the double angle. We have here cosine, then we will use cosine. Cosine square equal 1 plus cosine 2x all divided by 2. After that, we will substitute this value in the integral, and we will get this result. And after the simplification, we will have this integral. How we will solve this type of integral? By expand square. After we expand it, now the integral become more easy to solve. From the integral properties, we will distribute the integrals to the function, and we will get this value. What is the integral for this one? It will be x, and integral for cosine, it will be sine. Plus, this is the remaining integral, cosine square 2x dx. We will solve the remaining integral and then substitute the value in the equation number 1. And we will try to solve this remaining integral. How we will solve it? Same again. We will repeat the same step. Why? Because we have even power. For cosine, then we will use the double angle relationship, cosine square equal 1 plus cosine 2x all divided by 2. This is the formula, but notice here we have 2x, so the angle will become 4x. Be careful for this point. The formula it is x become 2x, but when the question we have here 2x in the integral we have 2x, then it will become 4x. After that, we will substitute this value in the integral. We will get this result. Now it become easy to find the solution for this integral. Integral for this one it will be x, and integral for cosine it will be sine. And we will get, this is the result of the remaining integral. We will call it equation number 2. We will just substitute the value for this remaining integral in the equation number 1. And finally, after the substituting the value, we will get, this is the final result, plus the constant number. Let's go to see another example. Find the integral of the following function: integral sine to the power 6 x dx. We have even power, then we will follow the previous step to solve this type of integral. 6 we withdraw 2, it will become 4. So it will become sine to the power 4 multiply sine to the power 2 x dx. Second step, we will use double angle relationship. We have here sine, then it will become sine square equal 1 minus cosine 2x all divided by 2. And we will substitute this value in the integral. We will get this result, and we will try to simplify the function, and we will get cube. How we will solve this cube? By expand the cube. After expand this a cube, we will get this result. And by using the integral properties, distributing the integral to the function to solve each function individual, it will become the integral easy to solve. The integral for this function will be x. The integral for cosine will become sine. We have remaining integral cosine square minus integral cosine to the power 3. We have only these two remaining integral cosine to the power 2 minus integral cosine to the power 3, and we will call this equation number 1. We will solve each remaining integral alone, and finally we will put all the final result in the equation number 1. So we will try to solve this integral cosine to the power 2 2x dx. How we will solve it? We have here even power, then we will use the same repeated step. We already here we have the quadratic exponent, so we directly no need to draw 2 from the exponent because we have 2, the quadratic exponent. So directly we will use the double angle relationship, cosine square equal 1 plus cosine 2x all divided by 2. Cosine square we have here in the question 2x equal 1 plus cosine 4x all to the power 2. Notice here x, it become 2x, we have here 2x it become 4x. Then we'll substitute this value in the integral. After the substituting the value, you will get this result. The integral is become easy to find the solution. The integral for this part, it will become x, and the integral for cosine, it will become sine. And this is the equation number 2. And let's go to solve the other remaining integral. We already solved this one, and let's go to solve the other remaining integral. Integral cosine to the power 3 2x dx. How we will solve it? Notice here we have odd power. So how we will solve it? We will solve it as we did in the previous lectures. We withdraw 1 from the odd power. We have a 3 here, we withdraw 1, it will become 2. So the integral will become integral cosine 2 2x multiply cosine 2x dx. And we will use the relationship cosine square plus sine square equal 1. We have here cosine square, then we will use cosine square. So the cosine square equal 1 minus sine square. Notice that we will keep the same angle, 2x, 2x. Later on, we will substitute this value in the integral. After the substituting the value in the integral, we will get this result. Second step, we will use the substitution method to solve this integral. We will take this part for our assumption. So u equals sine 2x, and after take the derivation for our assumption, du it will be equal to cosine 2x dx. And after divided 2 on both sides, we will get half du equal cosine 2x dx. Notice cosine 2x dx, it will be this part. And as we learned from our previous lectures, we will put the integral in terms of u. Now the integral is become easy to solve. After finding the solution for this integral, we will put the integral in terms of x. And this is the result of the remaining integral, and we will call it number 3. After substituting the value from the equation number 2 and equation number 3, we will get this final result for this integral. It is easy and simple. This is for today's lectures, and I hope it is clear, and see you next time.